Okay, so good morning, everybody. Good morning. We're gonna work on this. So I have my number. I have 394. How do I know that's 39? Oh, that's 3. I gotta do 3. 3. The top bead is not counted, so we have 3. The bottom bead's a value of 1. 1, 1, 1. When we're looking, we have 3, we have 9, we have 4. The top bead is a value of 5, and the bottom bead's a value of 1. So we have 4 of 1s. So the difference between this one and this one is there's the top bead. The top bead is a value of 5, and the bottom bead's a value of 1. Notice that the top bead is not touching this, so this is not 9. This is 4. So we're going to add 96. To add the 9 is plus the 10 minus the 1. So we're going to do plus the 10 minus the 1. And then we're going to do plus the 6. Plus the 6 is what? To add the 6, I want to plus the 10 minus 4. So plus the 10 minus the 4. So my final answer is that's wrong. So let's do that again. 9394 plus the 10 minus the 1. Oh, there we go. And then this one plus the 6. Plus the 6 is plus the 10. No, I'm right. Nope. There we go. So, yep. No, that's right. Okay. So our next number we're going to be adding is 95 to this number. This number here, we have, oh, Jojo, your brain hurts. You got to stop doom scrolling. Stop doom scrolling because your brain is just being active now. For the bottom beads has a value of 1. So we have 1, 2, 3, 4. There's 4 1s. And then this number is actually 90. 90 is the top bead is a value of 5 and the bottom bead is a value of 4. So we have 4 plus 9. This is 9. This is 490. That's what this is. And so when you're looking, this is 0. When none of the beads are touching this horizontal bar, this is what we call 0. So we have 9 and then 4. We have 4 in here. So this is 490. I want to add, oh, wow. Maybe that's too much. All right. Yeah, no, that's fine. So we want to add 9 to this. What do we do? We're adding 9. To add the 9, we need to understand concepts of how to plus the 5. I can't do this. All right, we'll do this. Hold on. We'll go back to this. I don't think I can do this. I guess I have to do that later. Maybe I'll try doing that later. All right. So here we go. We have our number. Let's figure out how to read the abacus first. That might be the best. I think that's a better way. All right, we're going to learn how to read the abacus. So we have our hundreds. We have our hundreds, our tens, and our ones. When we're looking, we have our hundreds, tens, and our ones. Thank you so much for liking the live. So we have this number. Notice that the bottom bead is touching this horizontal bar. Because the bottom bead is touching the horizontal bar, what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we can do some adding and subtracting, which was what I was trying to do in the beginning. But I feel like that's a little bit too much because you really need to understand the formulas. So we have this number is 10. Good morning, everybody. Good morning. Good morning.
Good morning, apartment. Good morning, doorway. Morning wall. Morning ceiling. Good morning, floor. Ready to start the day.
So this number is 10. How do I know that this is 10? 10 is a 1 and a 0. 1 and a 0. This is not 10. We're not combining the two columns together. What we're doing is we are looking at the number, and every number is represented in each column. Each column is a representation of the place value. So when we're looking, I have to find my... where did it go? Good morning. So is it binary? Kind of binary. Kind of binary. Because the horizontal bar is what tracks your numbers. Oh, I missed it. Where did I put it? The binary, it kind of tracks your numbers. I thought I had it. I have to find it. So if you keep the horizontal bar, take the horizontal bar, and if you add it to the horizontal bar, it is considered counted. So this is 10. So we're going to take that number, and then we're going to go to the next one. So the next one is, our next one is this. So we have the top bead is a value of 5. The bottom bead is a value of 1, like we had before. This was 1, right? And then we have 4 of them, 1, 1, 1. That's 4, and then we add the 5. Now we have 5. So this together is 9, and then we have 7. 5 plus 2 is 7. That's what that is. There's 1. Oh, there it is. There we go. All right. So we have our 497. That's what that is. How do I know the place values? Every place value, every column is a place value. So we have our ones, our tens, hundreds, thousands, 10,000s. You'll notice that there is a dot right here. This dot tells me that this is the ones place. So with this ones place, this tells me that it's the ones place. It's just a label. That's all it is. And you'll notice that the second one over here, the second one is to tell me, and for readability, that this is the thousands place. So when we're looking, we have the thousands and we have the ones. And we have our next number. So we have 597. That's what the question is. The answer, right? The answer is 597. And then we take it to the next number. Hello. Hello. Good morning, everybody. Good morning. Good morning. Good morning.
Good morning, apartment. Good morning, doorway. Good morning, wall. Morning, ceiling. Good morning, floor. Ready to start the day.
So we have our hundreds, we have our tens, and we have our ones. Good morning, Rob. So when we're looking at the abacus, right, what we're doing is we're understanding how to read the abacus. Anytime the beads are touching this horizontal bar, this is what's considered counted. So we have 4, 1, 1, 1. There's 4 ones here. This is 7. We have the top bead as a value of 5. We have the bottom beads a value of 1. So 5 plus 1, 5 plus 2 is equal to 7. We have this one, which is 5 plus 4 is equal to 9. So together, this makes 9. The whole number is 479. That's what that is, 479. And then we have our next number. Hello, everybody. Hello. Thank you so much for joining. That's not working. Okay. Oh, thank you. Future of the education. Thank you so much. I appreciate that. We have our next number. What we're doing is we're visualizing our numbers. We visualize our numbers to actually be able to add, subtract, multiply, and divide. But the biggest thing is to understand how to read the numbers. So we have hundreds, tens, and ones. We have our hundreds. There's 2, 1, 1. There's 2 here. There's 4 here. 1, 1, 1, 1. There's 4 ones. And then here, there is what? There's 3 ones. And then there's a 5. The top is a value of 5, so we have to add the 5. Together, this is short form content tutoring. Content tutoring? So we have our 247. No, 8. 248. That's what we're doing. So this answer right here is 248. And then we have our next one. That's what I call it. Oh, yeah, it is. It is a short form of tutoring. You're right. You're right. You're absolutely right. I do it every day, twice a day, sometimes 3 times a day. And we do the same thing. We learn how to read the abacus, and then we start adding, subtracting on the abacus. So this is the value of 5. This is a value of 5 plus 2, right? And then again, 5 plus 2. That becomes 7. So, well, I need to be here. Oh, ha! That's interesting. That's very interesting. Welcome. Welcome.
Step 2, greet the day, smile, and say, Good morning, city!
Good morning. This is so cool, way easier. Thank you, Sebastian. Please, for those of you that just joined, please keep your mind open to something different.
Now, open your mind to me, please. Open your mind.
After we learn how to read the abacus, we will do some basic arithmetic. That's what the abacus does. It just does basic arithmetic. Thank you, Sama. So when we're looking, we have Sam. A la booty. So we have this, right? 577. That's what this is. What we're doing is we're visualizing our numbers. So if you keep your mind open for something different, what we're doing is we're visualizing our numbers. To visualize your numbers, you'll be able to know and see what you're trying to do when you add, subtract, multiply, and divide. But the first thing to do is understand how to read the abacus. We have our hundreds, our tens, and our ones. What number do we think this is? The top bead is a value of 5. The bottom bead is a value of 1. The top bead is a value of 5. There is no bottom beads over here. There's a top bead of value of 5, and then again, there's 3 bottom beads. So this is 8, this is 5, this is 7. Thank you, Vesper. 8, 5, because the top bead is touching, and then, 7, 5, 8. Thank you, I Heart Yellow Cake, for the support. Thank you, Sam. Yes, thank you, Vesper. So we have 758. That's what that looks like. And then we have our next number. So again, what we're doing is we're learning how to read the abacus. For those of you that are here, we're learning how to read the abacus, and then after that, we'll learn how to start moving the beads and add and subtract, multiply and divide. You can actually divide on this thing, but it does take a little bit of understanding. So we have our next number. We have our hundreds, our tens, and our ones. Notice that the one bead at the bottom, this is 1. And we add the top bead, it is a value of 5. The top bead will always be a value of 5. Then we have 3 bottom beads, 1, 1, 1. This is 3, and then this is 2. So 1, 3, 2. But the top bead is touching up here, so this is not 1. Good morning, Robert! Good morning.
Good morning, apartment. Good morning, doorway. Morning wall, morning ceiling. Good morning, floor. Ready to start the day.
So this number would be 632. Thank you, Vesper. I'm sorry, hold please. So it's only the middle 3 that counts. It depends on what it is, right? You're not late, Robert. I just started. If you look, this is the horizontal bar. This is the label for the ones place. Notice that there's 2. Good morning, Stephanie. Good morning, Stephanie. Thank you so much for checking in.
Step 2, greet the day, smile, and say, Good morning, city.
So we have the dots. Do you see the dots? These are labels. We have the ones label, we have the thousands label. And when I bring it down, then every column can be represented. So we have our ones, our tens, hundreds, thousands, and then 10,000s. Oh, can't see that. Hold on. Thank you so much for the tiny diny. Right? So then after the ones is our decimals. We can do our tenths and we can do our hundredths. Thank you, Stephanie, for the tiny diny. Thank you, everybody. Thank you so much for liking the live. For those of you that are interested, there's an orange heart me if you want to be part of my community. It tells TikTok that you're a real person and that you like my content. That's what it tells. That's what it tells TikTok, that you like my content. And if you can tap, right? If you could tap and tell TikTok that you enjoy the content, tapping away would be very appreciative. Thank you. Because right now we're at 1,600. I know a lot of people are new to TikTok and not understanding how TikTok works. But as a creator, as a content creator, I also provide workbooks in Abacus, as well as going live and teaching every day and every night. Every morning and every night. So when we're looking, yeah, really easy once you understand the place value. Yeah, you know what? Once you understand it, you can't unsee it, which is crazy. Okay, so again, for those of you that are interested, this is me. All you got to do is tap, right? If you like the content, keep tapping away because this will help the algorithm and this will give me some likes. But in the essence, what it is it will push my live out to the FYP. So. Which book are we doing? Oh, we're doing this book. Thank you, everybody. Thank you so much for understanding. So we're doing this book. If you're interested, I do have this book available. It is pinned at the bottom. I did pin it at the bottom. If you're interested in this book, you do have the option to buy the abacus, either the 7-column abacus or the 13-column abacus. The difference is just that size matters. The colors mean nothing. So if you notice, this is a 13-column abacus. Good morning, Audrey. Good morning, Audrey. Thank you, Rob, for the tiny diny. How are you doing, Audrey? So this is a 13-column abacus, and this is a 7-column abacus. Here we go. And when we're looking, they're kind of the only difference is the size. The colors mean nothing. You're doing okay? Do you want to come on? Do you want to talk? I'm learning. Yes. So. It works exactly the same. Notice that there is the dots. We have our ones, thousands, millions, billions, and then trillions. So notice that they're grouped into different sections. Okay? So, but I'm going to go back to this one because I like the colorful one. No, I have a... Oh, okay. Oh, okay. I'll talk to you in a little... I'll talk to you later. Okay, so our number is 632. That's what this number is. So 632 is what our number is, and then we have our next number. So for those of you that just joined, what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we're going to understand how to how to do basic arithmetic. So the first thing we need to do is we need to understand that this is our tens. This is our ones. So we have our tens and our ones. We have 1 and 3. We have 1 and 1, 1, 1. There's 3 of them. So this is actually 13. We have our next number. So 13 looks like that, right? There we go. 13 looks like that. And we have our next number. So what number do we think this is? Good morning, everybody. Good morning.
Step 2, greet the day, smile, and say, Good morning, city!
Hello, Jay. Thank you so much for the rose. Jay Edward. Thank you so much for the rose. I just saw that. Okay. What is our next number? We have our hundreds, we have our tens, and we have our ones. We have our hundreds. Remember, the top beat is a value of 5, and when it touches, it is counted. So we have 5 plus 3 is equal to 8. We have 2, and then we have 4. So we have 5 plus, but then notice here, the top beat is not touching. So this is not added to the horizontal bar. That's why this is 2, and that is 4. If I had the 5B touching, this would be 7. But this is not the question, right? The answer is 2. If I had the top B touching here, this would be 9. But this is not what we want. We want 4. So we have 824. That's it. 824. 824. And then we have our next number. We have our hundreds, we have our tens, and we have our ones. What number do we think this is? Thank you, everybody, for joining. Thank you so much for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Thank you, wonton soup. Is it? Yes, thank you. It is 773. Well done. So we have 7. 5 plus 2 is equal to 7. 5 plus 2 is equal to 7. And then we have 3. 1, 2, 3. Thank you for the follow, wonton soup. And then we have our next number. So that's what it is, 773. And then we have our next number. We have, maybe it's too bright. There we go. Maybe that's better. All right, what's our next number? So we have our hundreds, we have our tens, and we have our ones. How do you use it? Shadow! That's what I'm doing. I'm using it. So all it is what number? Thank you, Rob. Yes, it is 770 because this is a 0. So notice that the top beat is a value of 5, and then there's 2 bottom beats. We have 2 and then 2. So 5 plus 2 is equal to 7. 5 plus 2 is equal to 7. So we have 770. Well done. Well done. Easy, right? Simple to use. Easy to understand. So we have our next number. I just explained it.
Do you understand the words that are coming out of my mouth?
Do you understand the words that are coming out from my mouth?
So we have our next number. We have our tens over here. So we have the 5, right? And then there's 3 ones. So together, this makes 8. We have 4, 1, 2, 3, 4. Together, that makes 4. Anytime the beads are touching this horizontal bar, thank you, Maker, it is 84. It's not 67, Chris. It's not 67.
Do you understand the words that are coming out of my mouth?
Do you understand the words that are coming out from my mouth?
So this one is 84. Thank you, Maker. Thank you, Robert. So what we're doing is we're understanding that the top beat is a value of 5, the bottom beat is a value of 3. 1, 1, 1. So when together, this becomes 8. This is 4. If I add the top beat, this would be 9. However, good morning, Merc. I don't have a turkey. Nah, you're right. You're fine. Thank you. Good morning, Merc. Thank you, thank you, thank you.
Step 2, greet the day, smile, and say, Good morning, city!
So notice that there's no hundreds because the beads are not touching this horizontal bar. So this is a 0. This is, hello, Fury. Call me more. They call me Fury. That's funny. So we have 8 and then we have 4. So the top beat is a value of 5. If I added it, if I removed it, this would be 34. 84, but I added it. This is now 84. That's it. So this book is available in my TikTok shop. This is a Abacus for Mazes. Abacus Mazes. It's a 3-digit. We talked about the hundreds, the tens, and the ones. So I just got here the 2 columns of the right mode. Oh, good. So that is a decimal, right? So when we're looking, we have our ones label. This is my ones label. When we put it down, I have labels: ones, tens, hundred thousands, 10,000s. The ones on the 2 right side is the decimal, because that's what happens with the ones. Just like when we're talking about money. Ugh. Right? Just like when we're talking about money. $2.05. So it'd be so this would be $2.05. Just like the tenths. Just like money, right? We have one of these in my mom's school. I mean, oh, that's great. You know, here's a question, Mister. Check to see how many beads it is. That's the difference. The difference is, check how many beads there are. So the other columns on the dot is a comma. Yes, exactly, makers. The other one is a comma. Just like it's for readability, right? Because there's a lot of columns. So in this question, it is thousands. So we have our 3,456. It is for readability. It's a little harder to see this, right? And so when we're looking, someone is helpful. Oh yeah, discalculate. Oh, that's very interesting. Sorry, thank you. That's very interesting, Wonton Soup. So we could do another one, right? We could do 73,000. 73,000, remember that this is the comma right here. This is 456 point, there's my decimal, right? 0.25. What are the giant ones for then? I don't know what you're talking about, Fury. So then guess what? I have this number here. This is a whole row of 5s. If this is a whole row of 5s,
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
so this is 55,555.55. So this is 10,000s, thousands, hundreds, tens, ones. And these are all 5s. And then we have our decimal, and then we have 5 and 5. Thank you, everybody, for liking the live. So we're going to continue on. You can do a whole row of 6, right? We're not combining these all together. Every number is an individual number. So this is all 6s. Here is all 8s. Every one of this is an 8. 8, 8, 8, 8, 8, 8. If I did this one, this would be 9s.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
So this is 99,999.99. The one we have is a 2 beat on top of it. It doesn't. No, the principles are different. Like the bigger abacuses, are they bigger or are they separate use? It depends on what the abacus is. So this is a Chinese abacus. A Chinese abacus is very different than a Japanese abacus. And here we go. So, oh, have a good one. You too, Rob. Thank you so much. I hope to see you in my next live.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Thank you, Busy, for the rose. Thank you so much. Okay, so, okay, mister, when we're looking, right, we have 1, 2, 3, 4, 5, right? Because we have 5 here, we're going to trade it in. That would be 5. We have 6, 7, 8, 9, 10. Because there's 5 here, we're going to trade it in to the top beat. Now, this becomes 10. Hello, yes man. Good morning. Good morning.
Good morning, apartment. Good morning, doorway. Morning wall. Morning ceiling. Good morning, floor. Ready to start the day.
So we have our next number, right? Because we have 10 here, we're going to trade this into that. That's how you do the Chinese abacus, but that's not what I teach. The concepts are kind of different because what you do in the Chinese abacus is you count up, whereas in the abacus, on the Japanese abacus, we use concepts. We understand the concept of how to make a 5, and we understand how to make a 10, and that's what we do, right? And so we'll go into that in a little bit, but the first thing we need to do is understand how to read the abacus and understand the difference. So when we're looking, notice that I could do the same thing on the abacus. Because I have my dots, this is my, I can choose any one of them to be my ones place. If I choose this one to be my ones place, this will be my thousands. But I could choose this one to be my ones place, then everything would shift over. Everything would shift over like this. So we have our ones over here. I haven't clocked. It didn't work yet. Variation. I bring up this. I like to bring this up to a considering math club. That'd be fantastic. Yeah. To do this in the math club, that'd be fantastic. So we have our ones, right? 1, 2. So you know what? We can actually relate it to Roman numerals. We do 2 on the Roman numerals. We do 3. This is what 3 is. We could do 4. That's what 4 is. And then we 5. The 5 is the top bead, right? The top 5 is the top bead. The Japanese abacus is more efficient because the Japanese came around and said, I'm going to make it more efficient. And that's what they did. They made it more efficient. So if you were to have the Chinese abacus, you could do it. You could do it like the Japanese abacus. You would just have to ignore the top bead and the bottom bead, and you just work with the middle beads. You could do that. But I don't teach the Chinese abacus. I teach the Japanese abacus. So we have 5 on the top, and then we have 6. 5 plus 1 is 6, and then we have 7. 5 plus 2 is 7, and then we have 8. 5 plus 3 is 8, and then we have 9. 9 is 5 plus 4, and then 10 is a 1 and a 0. That's what 10 would look like, right? 1 and a 0. So because we do this as our ones place, we can actually make a really, really small number. We can actually do 0.00001. That would be a really, really small number. So I'm going to take it back to here, right in the middle. This would be where I'm looking at. Let's move this one back to our ones place. So notice it's interchangeable, and it's all about for readability. And then we can do it with tally marks. We have 1, 2, 3, 4. 5 is a slash, right? Just like that. 5 is a slash. We have 6. 5 plus 1 is 6. We have 7. 5 plus 2 is 7. 8. 5 plus 3 is 8. And then 9. 5 plus 4 is 9. And then that would be 10. 10 is exactly the same. All we're doing is we're resetting this column and we move to the next one. So we could still do the same thing. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I've never seen other than the Chinese one. This Japanese one is more efficient. Yeah, the Japanese one has come around around the 16th century, and it's more modern, and a lot of the competitions is now done with the Japanese abacus. Like, they're starting to understand that it's a more efficient, which is crazy. And if you look at it, like, there's actually abacus competitions. All of the abacus competitions, I bet you they're all using the Japanese method. The Japanese abacus method. There's a person that has broken the world record of adding 100 add-ins under 30 seconds. And so all this person did is, I believe they did it with the abacus method. I believe they did it with the, hello, Reaper. Good morning.
Good morning, apartment. Good morning, doorway. Morning wall, morning ceiling. Good morning, floor. Ready to start the day.
So I do have different types of mazes. The reason why the mazes are is to help recognize the beads. So I have this one. Thank you so much for the follow, Micey. This one is a 2-digit number. We talk about the 10s and the 1s. This might be good for like first graders. The reason why is because we only talk about 2 digits. And it could be good for kindergartens if you don't want to do the preschool one. The preschool one is just learning their numbers, and I can show you that in a little bit. And then I give you this mask maze. The mask maze is to help cover the maze. The reason why, because the answers are on the maze. And so the idea is to cover up the maze like that. So for those of you that are interested, I do have these books available in my Abacus store. I'm sorry, my TikTok store. Or I have it available in my, over here. My name is Lynette. I've been teaching Abacus for 20 years. I have published 14 books. So if you have any questions about my books, let me know and I can walk you through them. But because I want you to have an informed, I want you to be informed when you buy. So this is my 2-digit number. This would be good for learning understanding how to read the beads. And then I give you this thing called the reverse maze. The reverse maze means that if you have this number, I'm going to do this. All right. If you have this number like that, then it is up to you to color in the abacus. Because I was trying to be more color oriented because I feel like coloring is very meditative. So if I give you the 7 and I do this. So the idea here is like this, I call it a reverse maze. I give you the path and then the idea is to, and the number, you're supposed to color in the number here. So this is actually 17. This is 29. And I have the answers in the back of the book. There we go. All right. So there is a 2-digit one. There's also a 4-digit one. If you're thinking about the kids are a little bit older. Hello, thank you Noah 1 for the follow. So this is a 4-digit one. A 4-digit one is exactly what it is. It's 4 digits. It's the thousands, the hundreds, the tens, and the ones. And so when we're looking, it's 4 digits. And again, you have the opportunity to color it in. In the beginning of the book, we talk about how to read the abacus. We talk about the single values, double values, triple, and then the 4-digit numbers. And then I give you again the maze, the mask maze, so you can cover it in. Good morning. Oh, thank you so much. Thank you so much, mister. I will see you in my next live.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
So here I already colored it in. But if I did this is what a page that's not colored in look like. What number do we think this is? We have our thousands. Don't forget there's a dot here for readability, right? So we have our thousands, we have our hundreds, we have our tens, and we have our ones. What number do we think that is? Good morning, everybody. Good morning. What number do we think that is?
Good morning, apartment. Good morning, doorway. Morning wall, morning ceiling. Good morning, floor. Ready to start the day.
It takes a little bit because now there's more numbers, but I can wait. Remember, the top beat is a value of 1. The top beat is a value of 5. Thank you, makers, right? So the top beat is a value of 5, and then there's 2 bottom beats. So this has become 7. There's no beads touching this column right here, the hundreds column. So this is why it's 0. And again, we have the top beat is a value of 5, the bottom beat is a value of 2. This is 7, and then we do it again. This is 2. So when we're looking at the abacus breaks it up into manageable chunks. Take it 1 column at a time. So yes, thank you. It is 7,072. Well done. Thank you, Reaper. So our next number is our thousands, our hundreds, our tens, and then ones. What number? I understand, Reaper. It's big fingers, fast typing. What number do we think that is? For those of you that just joined, please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Thank you, everybody, for liking the live. So what number do we think that is? If we're looking, remember the top bead, thank you, makers. The top bead is not touching here, so this is why it's 4. Because it's 1, 1, 1, 1. There's 4 ones, but over here, the top bead is touching, so that's why it's 9. So we have 5 plus 4 is equal to 9. And we do it again. Thank you, Big Lou. 5 plus nothing is equal to 5. And then almost, Mio. So when we're looking, this is 4. 1, 1, 1, 1. What I'm looking at, this is my ones place, so there would be a 0 over here. So it'd be point, like a decimal, 00. Very close, very close. The only thing is we're understanding how to read the place values. Thank you so much. I appreciate the question. I appreciate the comments. So when we're looking, every column is a place value. There is a dot. This is a label. This label tells me this is the ones place. This dot tells me that this is the thousands, like a comma. So it's for readability. So we have our ones, tens, hundreds, thousands, and 10,000s. This one is just the tenths and then the hundredths. That's what that is. So we have our next number, 495. Yep, there we go. So we have our next number. What number do we think that is? We have our thousands. We have our hundreds. We have our thousands. We have our hundreds. We have our tens. And we have our ones. What number do we think that is? So remember that this is the decimal, so this one would be 0.00. When you buy the book, does it come with the... You have the option to buy the Abacus. It depends on what book it is. So I put it all the beginning books, but because I didn't think the older books, the more advanced books needed it. So it all depends on which book it is. Thank you, makers. It is 770. That's what it is. So like all the mazes have the Abacus. Thank you, Reaper. The preschool book has the option to buy the Abacus. Oh, the Abacus for adults has the opportunity to buy the Abacus as well. And all the mazes, because I feel like that this is the beginning. This is the beginning. Because I think when you start getting to the other ones, it is, I think by then you should already have an Abacus. How the heck is that 770? How the heck is it not? The top is a value of 5. The bottom is a value of 2. That's how. The top is a value of 5. The bottom beats a value of 2. If you take a look, there we go. We have our ones. This is our ones. This is the label for the ones. This is the 2. The top is a value of 5. The top is a value of 5. This is how you get 7. 5 plus 2 is 7. 5 plus 2 is 7. This is 0 because none of the beads are touching the horizontal bar. This is 0 because none of the beads are touching the horizontal bar. That's how it's 770. Yeah? So then, we have our place values. There we go. Notice that this is the label. So we have our ones, tens, hundreds, thousands, 10,000s. Thank you, Reaper. Right. Yeah. Super easy. Simple to use, easy to understand. Okay. So, for those of you that are interested, so this is my 4-digit book. We talk about the thousands, the tens, the thousands, the hundreds, the tens, and the ones. Some of you may be wondering, well, what about me? Well, I did create, don't forget the singles. Ha! Yeah. Don't forget the singles. For those of you that are interested, I do have books for adults. If you're looking to improve, if you're looking to level up your brain,
Level up, 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 level up.
so I have a book for adults. What we do is we only do adding, subtracting. It builds confidence and promotes critical thinking. The reason why is because what I did is I combined these. There's actually these 4 concepts that you need to know. There's how to make a 5, how to subtract a 5, how to make a 10, how to subtract a 10. All of this is combined into one book. And then I talk about how you Tetris your way through. So the way I have it, it's not just a bunch of boring questions. What I do is I have given you activities. So this is pixel art. This is how you do the subtraction. This is pixel art. Pixel art, I know it's super simple. This is super simple. This is so easy, right? Because if you do it on the Abacus like this, so I have 9 on the Abacus. I have 9 on the Abacus. I want to take away 5. All I got to do is this. Take away the 5. Now, why is it super simple? Because I want you to see what it looks like when the beads move. That is why. That's the only reason why it's so simple. So we have our next number over here, right? We have 7 over here. We have 7 on the Abacus. I want to add the 2. Adding the 2 means I'm moving 2 beads up like that. So my final answer is 9. Again, Do the abacus, because you need to see how the beads move. There's not a lot of chances. The questions are going to be simple, but to see the beads move is another thing, right? Don't discount the concept of moving the beads. So go through the motion of moving the beads. Then we start doing the how to make a 5. How to make a 5 is one of the core concepts of adding and subtracting. This is not just abacus. This is basically adding and subtracting. And we understand the concept of how to add the 5, and we're going to do how to add the 10. Once you know all of this, then you will be able to add and subtract at scale. So here is the plus 5, and then I give you some example questions, and then this is minus 5. I give you some more example questions, and then I give you an activity. Then we have the summary of how to make a 5. Notice, if you know how to add, you will know how to subtract. It is very similar. The only difference is the sign. If you know how to add, we're going to add the 5 minus the 2. Here we want to add we want to take away the 2, take away the 3. We minus the 5 and plus the 2. So that is one of the concepts. And then we go into adding of the 10, and I give you some examples. We talk about the beginning parts of multiplication. Multiplication on the abacus is just repeated addition. And then here, I want you to solidify the concept of using the formulas. I know you could do this all in your head, but the point is to utilize the abacus as the tool it is. And it is a math tool. It's a visualizing tool. So we have our making of the 10. If you know how to add, you will know how to subtract. It's exactly the same, just happens to be the opposite, right? And then here's a framework. The framework will help understand the workflow of each question. So we have the question is 7 plus 4. Here we go. 7 plus 4. The question is 7 on the abacus. I want to add the 4. There's not enough beads to add the 4. What do? Do I have enough to add the 4? Yes or no? No, I don't have the room to add the 4. I'm going to use this plus the 5. Can I use it? No, because I'm already using it. So that means I have to go down here. I want to add the 4. To add the 4, the formula is to plus the 10 minus the 6. So all I got to do is plus the 10 minus the 6. So my final answer becomes 11. How did I do that? Okay, let's go back. So then that's the rest of this book, just so you know. So how did I do that? Let's take it one step back, right? One step back. The first thing we need to do is understand how to move the beads. This one is cucumber pre-pickle. The way you teach works my brain. Good. Hopefully it activates your brain, right? So that was this book. This book is I pinned it down at the bottom. This is Abacus for Adults, and so we're only doing adding, subtracting. It builds confidence and promotes critical thinking. How does it promote critical thinking? It promotes critical thinking because you got to look at the number and see what we're trying to do. You want to observe and analyze the question before you just flat out just do it. Don't just do it. Right? The idea is to read the abacus, read the numbers first before you understand. And that's what we're going to do right now. So here is my next book. This book is Preschool, because I was trying to get the kids young. So I have a bunch of books. So if you want me to explain what these books mean, let me know. I'm going to go run through this book as well. This is also pinned at the bottom of my it's pinned at the bottom. So this is Preschool Abacus for math, Preschool Abacus Math. Now what I want to do here is I'm just showing the kids what the numbers are and how does it relate to everything, right? How does it relate to the snakes? How does it relate to the number? How does it relate to the abacus? So the idea here was to get the abacus involved early, because if they already know, they're starting to count on their fingers and their toes, and they're already counting their cars and their apples and their grapes, then you can start introducing abacus to those kids. The reason why is because you want to relate the abacus to the numbers. So we have 0, 1, there's 1. This is 2, that's 2. This is 3, that's 3, and this is 4, that's 4. So what we're doing is it doesn't matter what the path is. The concept is, I just wanted them to practice their fine motor skills, but their idea is that they have to find where the abacus is, where the number is. And then here is a 1-to-1, right? And these are just activities. There's pixel art, and then the pixel art again is just to get them to understand what the 4 looks like. What does the 0 looks like, right? So it's not. So then here is the abacus, and they can color in whatever color key that they want, because I wanted to give them that freedom of coloring whatever they want. And then we have color by number, and then the next lesson is lesson 5 to 9. Numbers 5 to 9, and again I try to break it into smaller chunks. So we talk about just those basic numbers and what they mean, and then tracing. So sometimes I have my students come back here and just trace the number because they're having a hard time of writing their numbers. So this is the 9, right? And then there's more activities. And then we start talking about counting forward. We start counting forward, right? If I give you 8, what's after 8 is 9. If I give you 5, what's after 5 is 6. So the idea here is that they would have to color it, they would have to make a circle, and then they'd have to tell me what the numbers are. Because they know how to add, they know how to count forward, they should know how to count backwards, right? So if I give you the number here, counting backwards, and I was trying to signify we go backwards. So if this is 8, we go back to 7, and you just take away the 1. And then if you know what's counting backwards, then you can figure out what comes in between. If I give you the first number is 8, I give you the second number, which is 6, my middle number should be 7. And then there's the opposite. If you know what's in between, you'll know what's surrounding. So the idea is the concept of the relationship with the numbers. And then we start going into bigger than and less than. And then here I want them to write the words to practice their handwriting. Okay, so we're done with that. Now we're going to get into some adding and subtracting. So this is one of the critical things of understanding. Thank you everybody for liking my live. In Abacus world, what we do is we need to understand that we need to look at the second number. Mainstream, you took at the first number or you look at the result. You don't need to do that. In Abacus world, what we do is we need to look at the middle. We need to look at the second number. The second number is what we need to understand. Why? Because that's what's going to tell us whether or not we're going to use a formula. So the way this book is broken up is we want to add the 1. When we add the 1, what does that look like? So we have our number. We have 7 on the abacus. We have 7 on the abacus. I want to add the 1. Add the 1 just means this, right? All we got to do we have enough? Yeah, we have enough. We're going to add the 1. That's what it is. So my final answer is 8. We could do it again with the 2. We have 6 on the abacus. 6 on the abacus. We want to add the 2. We're going to add the 2. That's all we're doing. We're adding the 2. So my final answer is 8 again. And then we could do it again with the 3. Well, guess what with the 3? The 3, very similar. You could use the dots, right? Just like mainstream math, you could use the dots. We can do that. Or you could use the tally marks. You could do that too. But in Abacus, it would be interesting because you could see it subitizes. 5 plus 3 is equal to 8. That's what 8 looks like. And then guess what? We can actually subitize. We could see the number and we know what it is, right? Now, guess what? If I want to do 50 plus 30, 50 plus 30 gives me 80. Subitizing means that if you look at the number, you know what it is. This is 80. How do I know this is 80? Because it's a 0 in the ones column. This is a 8 in the tens column. You could do the dots, but that's a whole lot of dots. Not a problem, right? So what I'm showing you is I'm showing you a different way of visualizing your numbers. You can do the dots to show them the quantity, right? Not a problem. There's room for everybody. I don't know why people think that we only use a calculator. You can use a calculator. There's no problem. Use a calculator. I use a calculator. I use the abacus to activate my brain. I use the abacus as a hobby, right? Because for those of you that are interested in learning something different, learning something new, learning the abacus would be one of those things. Like Sudoku, right? Crossword puzzles, jigsaw puzzles, word searches, all that stuff. Even chess, very strategic. We play chess all the time. You could do the abacus too, if you want to learn something different. And what we do is we do basic arithmetic. We add, subtract, multiply, and divide. So in this, right, I showed you what 80 looks like. Now, guess what? If I did 500 plus 300, it is now 800. That's a lot. But you can't. It's harder to show you on the dots. That's all I'm saying. But it's easy on the abacus to subitize that this is 800 because we have 5 plus 300. These are hundreds because this is the ones, the tens, and the hundreds. Thank you everybody for joining. Thank you everybody for joining, right? So we do it again. If you know how to add, right? Adding means you go to the horizontal bar. That's 4. I want to subtract. I love your videos. Oh, so math murder my thank you, Cole. Thank you, Cole. If you know how to subtract, you will know if you know how to add, you know how to subtract. I have 4 on the abacus. I want to take away the 1. Take away the 1. This is not negative 1. This is take away 1. Hello, Mason. Good morning. Good morning, Mason.
Step 2, greet the day, smile, and say, Good morning, city!
So, here, my question is 2. Again, if I have 2 on the abacus, I go 2. 2 is adding to the abacus, you go to the horizontal bar. We want to subtract the 1, you want to take away the 1 like that. That's all you're doing. So the difference is what? You can actually see that we're removing it. Where they have a whole section in school to explain what subtraction is, and kids still don't understand what subtraction is. But on the abacus, you could see what we're doing. We're just taking it away from the horizontal bar, right? So here, let's do minus 2. What does minus 2 look like? Same thing. So if I have 3 on the abacus, I want to take away 2. Can we do it? Yes, we could take away the 2. All we got to do is remove it away from the horizontal bar. The very act of removing it away from the horizontal bar is what we're trying to show you, is what the abacus will show you. As a child, as a student, as an adult, as a whoever, you'll see that when you want to add, you can subtract. If you add, you go to the horizontal bar. When you subtract, you go away from the horizontal bar. Thank you, Mio. Same thing with the 3. I have 4 on the abacus. I want to take away 3. Can I do it? Can I do it?
Come on, do it. Do it.
I take away 3. So my final answer is 1. So then we start going into understanding how to make a 5, right? No. We're starting to add the 5. Add the 5, take away the 5. Add the 5, take away the 5. Easy, right? If I have the 6, right? 5 plus 1 is 6. 5, 1 beat on top, 1 beat on the bottom is 6. When if I have 1 already on the abacus and I want to add the 6, what do? To add the 6, all I got to do is 1 beat on top, 1 beat on the bottom, you bring it together. That's what 6 is. And then we have 7. Our final answer is 7. 7 is what? 1 beat on top, 2 beats on the bottom. If I have 2 already, and I want to add 7, 1 beat on bottom, 1 beat on top, 2 beats on the bottom, you bring it together. So my final answer is 9. So what I'm showing you is I'm showing you how to add, right? But now, guess what? I have 9 on the abacus. I want to take away 8. Take away 8 is what? 8 is 1 beat on top, 3 beats on the bottom. You take away 8. So my final answer is 1. That's it. That is this book. This book goes all the way up to 9. We don't do 10 because then I would have to explain what the place values are. And then the book gets really huge. That's what the next books are for. And then in mainstream, which is interesting, they want the kids to memorize how to make a 9. I'm like, why do we need the kids to memorize? We don't need to have the kids to memorize how to make a 9. Why? Because on the abacus it already shows us. We have 1 on the abacus. I want to add 8. All I got to do is add the 8, right? If I want to have 2 on the abacus, I want to add 7. Add the 7. Look, there's my 9. So I have my availability is already there for me. I want to add the 4. 4 to make a 9. I don't need to memorize that I need to add the 5 because I can just see it on the abacus. This becomes 9. And then same thing, right? 3. 3 on the abacus, right? And then I want to add the 6. Add the 6. So my final answer is 9. There we go. There we go. So that is about the 9. So that is this book here. And then what we're going to do is we're going to get into some adding and subtracting. That makes mindless repetition. Is that what you're trying to say? Repetition? Yeah, exactly. It is mindless. But see, the thing is they want they want the kids to memorize a lot more than they need to. Abacus, you don't need to memorize. You just look at the abacus and you just see it. Yes, I understand. Right? You look at the abacus, you get to see it. And so when we're looking, hello, Ash. Right? What we're going to do now is we're going to understand how to make a 5. We teach the kids in mainstream, they teach the kids how to make a 5. But I question, what do we do it for? This is going to be so good. All right. This is preschool level math? No. This is the fun grade. It's all sorts of math. It's the beginning parts of learning how to read the abacus. So this is an adult book. If you're interested, I do have an adult book, and it encompasses everything that we're learning right now. So we talk about, there's the mazes, then we start talking about how to add the 5, minus the 5, plus the 5, plus the 10, minus the 10, right? And we're going to do that right now. Kids like learning so good. Thank you, Red Mom. Thank you. Yes. So for Red Mom, if you want to learn before the kids, or you can learn while the kids, it's up to you. Because I try to make my books as explanatory as possible. If not, I do have a membership if you want more hand holding. I do offer that. However, I do have my books are pretty self-explanatory. But I know some people enjoy video, and so that's one of the things is I got to create more videos so you can understand it. Yeah, makes it more accessible for all ages. Yes, exactly. And so I'm trying to. So you don't have to be kindergarten or first grader to go start Abacus. I'm trying to start Abacus at every stage. So I'm at the moment right now. I'm creating a level 1 book for first grade, and then I'm going to do multiplication and we go to do division. But the first thing we're going to do is we're going to understand how to make a 5. This is going to be fantastic. You're going to like this. Now, in Abacus world, we don't need to memorize what 4 plus 4 is. 4 plus 4, we don't want to memorize doubles, and we do not want to memorize near doubles. What we want to do is we want to understand concepts. The concept is super easy. I know this is easy. I know you know this is 8. This is not here to question your intelligence. What I'm showing you is a concept. The concept is that you need to add in order to subtract. You need to subtract in order to add. Now, why? I have 4 on the abacus. I'm going to use these coins. These are going to be pretty obsolete pretty soon. I got to use the bricks. I'm going to use the bricks pretty soon. But let's do this. Let's do like a few ways to do this. If I have 4 in the abacus, I want to add this 4. Always look at the second number. The second number is what tells you whether or not you need a formula. Why? Because the 4 is already here. This 4 is already here. I have no more room to add the 4. So what's going to happen is I need to utilize the 5. Why? Because I have enough for 4. If I give you a nickel, I need change back. I need to take away 1. So my final answer is 8. Does that make sense? So when we're looking, we can add the 5 minus the 1. So my final answer is 8. Okay, let's try another way. We have 4 on the abacus. Here's my 4, right? In mainstream, in public school, what do? They tell you count up. You could count up, but that's not what the abacus way is. Why? Because abacus talks about the concept of how to make a 5. Here is 4. I want to add another 4. Notice I have no more room to add this 4. Guess what? I can round the bottom bead. I can round the bottom 4 to 5. I want to round it to 5. Why? Because I know 4 plus 1 is equal to 5. 1 has to come from somewhere. 1 has to come from where? The previous number. So you take away 1 from here. You give away 1, right? You give away 1. I give away 1. Guess what? I'm going to add it and regroup at a smaller level. This now is regrouped to make a 5. What did I just do? I just made a 5. I just added a 5. So what did I do? I had to take away here to add my 5. Now I have room to add the 5. Does that make sense? So what we just did is we did a concept of how to make a 5. We can do it again. Notice it's not a near double. We don't need to memorize near doubles. What we need to do is we need to understand how to make this 4. Look at the second number. The second number is always going to be the key, right? When we're looking, we have 3 on the abacus. I want to add 4. To add the 4, I want to round this to 5. To round this to 5, we got to plus the 1. Plus 1 has to come from somewhere. Plus 1 has to come from the previous number. So you take away 1 from here. Now I have made, and you add it to here, I have now made a 5. So it's the beginning steps of regrouping. Yes, Samantha, the top bead, yes, the blue bead is always going to be a value of 5. The bottom beads are always going to be a value of 1. Well done, Samantha. Right? That's what I'm saying. Just sit around a little bit. I explained the same thing over and over again. You know what I mean? Like, people come in and they start barging. It's like, I don't understand. I'm like, well, hold on. Hold on. Just sit back a little bit. Thank you, Samantha. Thank you. That's exactly what it is. So let's do it again. Guess what? We can do it again. We have 2 on the abacus. We have 2 on the abacus, right? I want to add 4. To add the 4, what do? We're going to add the 1. We're going to round this up to 5, right? We want to round it up to 5. So our answer is going to be, we got to add the 1. Where are you going to get the 1 from? The 1 comes from the previous number, from here. The 1 comes from the previous number. We add it to the 5. We add it to the 4 to make a 5. We rounded this up to 5. So my final answer is 6. 5 plus 1 is 6. That's it. Simple to use, easy to understand. It's a concept. This is the concept. The concept is that you need to subtract in order to add. So it's kind of like cars.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
Right? We had to subtract in order to add. Why? There's a reason why we need to know this. That's the reason why. So we want to round this because of the limitations of the abacus shows you that we need to use these things called formulas, right? That's when the kids do this. They're using the formulas to move the beads, right? In their head, they could see the abacus. In your head, you're going to be able to know how to move the beads. Can you do it mentally? Yes, you can do it mentally. There's certain parts you can do mentally. Understanding this, you're going to know to do this mentally because it's a very, very common concept. In Abacus world, it's one of those solid foundational concepts. Thank you everybody for liking the live. So we could do it again. I show you the different scenarios, but it's the same number plus the 4. We have 1 on the abacus. I want to have 4, right? What am I going to do? I still have to take away 1 to make this a 5. I still got to take this away to make this a 5. So I've made a 5. So my final answer is 5. Make sense? So I like this one better than the coins. We could do it again. Thank you, Clip Monsters. Thank you, Charlie. We could do it again. Right? We have 4 on the abacus. I want to add 3. Guess what? How do you add 3? We know what? We know on the abacus, we know to make a 5 with a 3, you need a 2. The 2 has to come from somewhere. The 2 has to come from what? The 2 comes from the first number. The 2 comes from the first number. The 2 comes from the first number. So you give away 2. You give away 2. You add it to your bottom number. Now it's making a 5. You made a 5. So my final answer is 7. 5 plus 2 is 7. Because I made a 5. This is my 5. We could do it again. We have 3 on the abacus. We have 3. We're not memorizing 3 plus 3. We're not going to memorize it. We're not going to memorize near doubles. What we're going to do is we're going to understand, how do I make a 5? Right? So I have 3 on the abacus. I want to make a 5. To make a 5, what do? Plus the 5, what do? Here's my 3. 3 plus 2 is equal to 5. 3 plus 2 is equal to 5. Here's my 3. I need 2. 2 comes from the previous number. So you got to take away from the previous number, and then you add it to the 5. So now this becomes 6. 5 plus 1 is 6. 5 plus 1 is 6. That's the concept, right? If you know how to add, you know how to subtract. Guess what? If I have 6 and I want to take away 3, what do? Take away 3. You got to break the 5. And then you add this back to the collective. You break the 5 and you add back the 2. If you know how to add, you know how to subtract. It's exactly the same, just the opposite, right? Same thing. So if I had 7, if I have 7, I want to take away 3, what do? I have to break the 5. You break the 5 and you add this back to the collective. You add back the 2. So my final answer is 4. If you know how to add, you know how to subtract. Simple, right? It's just the opposite. It's just like walking forwards, walking backwards. How can they visualize when the go bigger than single digits? Oh, easy. Here's a bigger number. So we have 1, 3, 5, 7. 1, 3, 5, 7. We need 7, right? 1,357. Guess what? I'm going to add 4,331. Same thing. Can you add the 4 here? We're looking at our number. Can you add the 4 here? No. What do? You know, plus the 5 minus the 1. I want to add 3 here. You know this. How do you add the 3? Plus the 5 minus the 2. Can I add the 3 here? Yes. All you got to do is add the 3. I have enough to add the 3. Do I have enough to add the 1? Yes, I have enough to add the 1. So my final answer, what's my final answer? So on the abacus, what is my final answer?
Bueller. Bueller.
Yes.
Bueller. Bueller.
Yes, Mio. Yes, Red Mom. Yes, it is 5,688. So that's how you get to bigger numbers. Does that make sense? Single digits. You take one number at a time, one column at a time, and see if you can add it. That's why Abacus makes it into smaller chunks. Abacus makes it into more manageable chunks. When we start looking at things, we want to understand it as single digits, because that's what we're doing. We don't need to make it bigger because our brain can't think that big. If you really think about it, even when you're adding, right? Do you start from left to right? I like to start from left to right. It's up to you. You can go from right to left. You can try both ways. You can try both ways. Because you're going to start noticing going from right to left and left to right. You're going to start noticing left to right is a little bit easier, and it seems more like you're counting forward. Some abaci yes. Thank you, Candy. Yes. So for some of those abacus that has 2 beads on top, that's what this is. This is a Chinese abacus, and Chinese abacus is very similar to a Japanese abacus. The Chinese abacus, the top bead is a value of 5. 5 plus 5, 5 plus 5 is equal to 10. Notice it's the same concept. You need to go to the horizontal bar to add. So we count 1, 2, 3, 4, 5. Because we have 5, we're going to trade this in to the top bead. We trade that in, and there's 5. We have 6, 7, 8, 9, 10. And then because we have 5 here, we're going to trade this in to make this a 10. So we have 10 up here, right? Because we have 10 here, we're going to trade this in to make this a 10. So the idea is to always trade in. Now that's counting. Counting is a little redundant. But when you start adding and subtracting on the abacus, it does work itself out. But I don't teach on the Chinese abacus. I teach on the Japanese abacus. So the Japanese abacus is very similar. We have 1, 2, 3, 4, and then 5. The top is a value of 5. And then we have 6, 7, 8, 9, and then 10. 10 is a 1 and a 0. So they took out the redundant steps of trading in. But the Chinese abacus, they do a lot of counting up. It's easy to count up with the Chinese abacus. With the Japanese abacus, we have to use formulas. We need to use concepts like how to make a 10 and how to make a 5. You understand these two concepts, you can do this at scale. Right? All right. So that is about how to make a 3. Does that make sense? And we're going to keep going. I mean, there's a whole curriculum. There's a whole set what we're doing right here. But understanding the concepts, right? So understanding the concepts is what? Let's do 2, right? Oh, good, Mio. We'll do 2. Why are we doing 2? Because there's a set. You know how to do the 4. You know how to do the 3. You'll know how to do the 1. You'll know how to do the 2. You'll know how to do the 1. So if anybody's interested, I do have my books available in my TikTok shop or over here. My name is Lynette. I've been teaching Abacus for about 20 years. And I'm not going to gatekeep anymore. So I started to do this online just to get it out the door and just to show the matrix what an abacus is. Welcome, everybody.
Welcome to the real world.
Right? So we're going to continue on. Same thing. See, notice we're compounding our knowledge. We're not doing different strategies. We're compounding our knowledge. It's the same thing, but just different numbers. We have 4 on the abacus, right? 4 on the abacus. We want to add 3. We want to add 2. Adding 2 is what? You need to get the 3 from somewhere. 3. We got to get the 3 from somewhere. Where does the 3 come from? The 3 comes from the previous number. The 3 comes from the previous number. So you got to take away the 3 in order to make a 5 here. So I've made my 5. My final answer is 6. I've made my 5. My final answer is 6.
This is the way.
This is the way. This is the way.
Okay? So we could do it again. If I had 3 on the abacus, there's my 3. And I have 2. 3 on the abacus, I have 2. Guess what? I got to take away here to make a 5. So I take away here to make my 5. Concept is very similar. It's adjacent concepts. Adjacent comprehension. So I finally made my answer. It's 5. Because I took away the 3, I need to add the 5. And there we go. So guess what? Let's say we wanted this one, 2 plus 2. Do we need to use a formula? No, we don't, right? That's why you have to check the look. Hello, Ebony. Good morning, Ebony.
Step 2, greet the day, smile, and say, Good morning, city!
Thank you, Andres, for the follow. Good morning. Good morning. So we want to add the 2. Notice there's enough to add the 2. Can you do it?
Come on, do it. Do it.
Add the 2. So my final answer is 4. So what we're doing is we got to pay attention to the second number. The second number will tell you whether or not we need to make a formula, right? Make a 5. Oh, you're welcome, Toto. Right? So I'm showing you the different scenarios, but that's the way the abacus is done because, and that's the way we do adding and subtracting on the abacus. Hello, TNT. Yes. So far, the trolls have not been too rampant today. The kids are all back in school, so they don't have time to spam me. Hello, TNT Blaze. Thank you. Good morning. Good morning.
Good morning, apartment. Good morning, doorway. Good morning, wall. Morning, ceiling. Good morning, floor. Ready to start the day.
Yeah. So, again, right, we can do it again. We have 3 on the abacus. I want to add the 1. Adding the 1's kind of, there's not a lot of questions to add the 1, right? So, do I have enough? Yeah, add the 1. There's no formulas involved, right? I'm not saying that everything has a formula. There's always a time and place for everything. So then, we have this one, right? We want to add the 4. We add the 4, and we want to add the 1. To add the 1, what do? To add the 1, we plus the 5 minus the 4. Why? Because 1, we need to find the 4 to make a 5. I want to be challenged. Okay, hold on. What is an abacus? An abacus is a counting tool. All it is, it's just a math tool to help you visualize your numbers. So when we're looking, this is 5, and then we have 6. 5 plus 1 is 6, and then we have 7. 5 plus 2 is 7, and then 8. 5 plus 3 is 8, and then 9. 5 plus 4 is 9, and then we have 10. 10 is a 1 and a 0. I want to be challenged. All right, I got it. So when we're doing this, you need to tell me the formulas. Don't tell me what the answer is. And that's the biggest thing is everybody keeps telling me the answers like, no, 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 no. I want to know the formula. Oh, you know what? We'll do this one. I need paper. All right, here we go. Okay. Can you see that? What number do we have? Oh, hold on, hold on. There we go. What number do we have? What is the first number? On the abacus, what is the first number? We have our hundreds, our tens, and our ones. What number do we have? Thank you, Andres. Yes. 1, 2, 3. We're going to add. What's the second number? What is our second number? Thank you. It is 5, 6, 5. Thank you, Mary. Thank you, Mio. Thank you, Andres. So when we're looking, we want to add the 5. We want to add the 6. We want to add the 5. So what's my answer right now? What's my answer? $688. Well done. Right? Okay, so let's do another one. So what we're doing is we're learning how to read the abacus, and this is what we call simple addition. Why? Because we have enough beads. What is my first number? What is my first number? I have my hundreds, my tens, and my ones. My first number, this one right here. Thank you, Andres. 613. 613. So what's my next number? So we want to add. What's my next number? Thank you, Mary. Thank you, Jessie. Thank you, Diggity. Swidiggity. Thank you. Thank you, Swidiggity. Yes. 221. So you add the 2, add another 2, and add the 1. So what's my final answer? Thank you, Jessie. 834. 834. Thank you, Jesse. Missed the 5? Oh, interesting. I always start from the top when I read it. So if I see the 5, then I add it. If I don't see the 5, then I don't add it. I always start from the top. So that's why I know that this is 8, this is 3, because the top is not touching. And again, this top is not touching, I know this is 4. So the answer is 834. It's a lot easier than I thought. It is easy. Simple to use, easier. Hello, Jess. So this is my book. This is my Abacus book for adults. I pinned it to the bottom of the... What's my next number? I see now. I'm going to do more. Thank you. 8517. 8517. What's my next number? Thank you. Thank you, Mary. Thank you, Andres. Thank you, Jesse. Thank you, Mio. 31. Yes, it is 31. I want to add the 3. So all I got to do is add the 3. 1, 1, 1. I added the 3. And then I have 1. So what is my final answer? I cover up the questions just in case you want to try to do it, right? The idea is to make sure you understand how to read the abacus. Thank you for the follow, Valentino. Thank you, Jesse. Yes. 8,548. Thank you. So, Manny, just for... Red Mom, don't forget the top bead. The top bead will always tell you that this is a value of 5. So now you can add 5 plus 3 is 8. We have 4, 1, 2, 3, 4. Manny, does that make sense? So anytime the beads are touching this horizontal bar, it's being counted. So we have 5, but the bottom beads are not touching. Thank you, Mary. It is. So the bottom beads are not touching, this is 5. If the bottom bead's touching, that'd be 6. If the 2 bottom beads are touching, this would be 7. If the 3 bottom beads are touching, this would be 8. And this, right? If 4 beads are touching this horizontal bar and the 5, this would be 9. But the question is actually 5, right? The answer is actually 5. This is 8. 5 plus 3 is 8. This is 5. This is 4. Why? Because the top bead is not added, so this becomes 4. If I remove this, this is 3, right? This is 2, and then this is 1. Every column is a place value. Every column is a place value. We have our 1s. There's a dot here. Oh, you can't see that. There's a dot here. Thank you so much, Valentino. There's a dot here. This dot tells me this is the label. This label tells me it's the ones place. So when we're looking at it, this is the ones, the tens, thousands, hundreds, thousands, and then 10,000s. Notice there's another dot. This dot is for readability, like a comma. So my ones and my comma, this is my thousands. Just like the readability for this. Excuse me. We have 3,000, comma, 456. Point. These are my decimals. Right? The readability is nice when there's a comma. It's a little bit harder to read this. A little bit, right? But when there's a whole string, then the readability becomes very interesting. So let's do this one, right? We can do 73,456. Point, we have our decimals, 25, 2 and a 5. If we have a whole row of 5s like this, here's a whole row of 5s.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So we're looking at 55,555.55. Yeah, yeah. Once you see it, you see everything.
Oh, I can see everything.
Right? Once you see it, you can never unsee it. So is the top 0? No, the top is not 0. What? Is the top 0? No, the top is not 0. The top is 5. 55555.55. If I did this and cleared my horizontal bar, that's what 0 would be. Right? Oh, yes, that's right. I see what you're saying. Yes. So if you cleared it like this, yes. So when you're looking, if I did this, this is a whole row of 1s. This would be 1s. We could do a whole row of 3s. That would be 3s. You can do a whole row of 9s. Like that. If you do a whole row of 9s.
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
That's it. So it's 99,999.99. Okay, you know what? Here. Well, what's 10? Exactly what it is. If this is 9, what's 10? 10 is a 1 and a 0. That's all it is. 1 and a 0. Because I have my 1's place and my 10's place. So this is basic abacus. What does the advanced? Can they do more complex math? The only complex math they can do, excuse me, the only math that we do on the abacus is add, subtract, multiply, and divide. Because if you think about it, if you really, really think about it, this was invented around the Mesopotamia era, right? In the Mesopotamia era, did they have complex math? No. Complex math happened more modern, right? When we start doing roller coasters and flying, and we need to understand like the surroundings of everything, right? So understand where complex math comes from. Complex math is actually modern math. When you do calculus, when you do pre-calc, when you do trigonometry, when you do algebra and geometry, all that stuff, that's all modern math. So that's different than abacus. Abacus just shows you the number. If I can get to 20,000, we'll do multiplication. How about that? If I can get to 20,000 likes, we can go to multiplication. Yeah. No. It makes perfect sense. So no, we don't do, this is not the end all. I'm not here to end everything, right? This is just building a foundation. That's all it is we're building a foundation. Does that make sense, Garrus? Yeah. This is just a foundation to get number sense, strong number sense. And then the idea also is we don't want to clutter our brain with all the different strategies on how to add and subtract. You know the basics of adding and subtracting on the abacus, then you have more room in your brain to start understanding how to do algebra, trigonometry, geometry, calculus, infinite math, finite math. You know what I mean? So you have more room in your brain to figure out all that part out. But you have a solid foundation with abacus. You have a solid foundation of the numbers are. That's what I'm here to do. I'm here to provide a solid foundation of numbers. Yeah. All right. So, wow, everybody. Thank you. Yeah, if we can get to 20,000, I will go into some multiplication. So I guess we're done with this. Huh. I gotta go get ready for multiplication. Okay. All right. I'm getting ready for multiplication because I have a lot of papers. All right. So So anybody else have any more questions? Valentino. Oh, thank you, Valentino. Yeah, not a problem. Yep. Yeah, let me know if you have any questions about abacus and math and what the point is. Like, we all use calculators. I'm not saying not to use a calculator. You can use it. That's fine. But now but knowing the abacus, you have a stronger idea of what numbers do, right? Because a calculator is like a black box. If you don't know what's inside the box, you don't know what's going on. I'm showing you how to do it. I'm just showing you how to level up your brain. Because why? Because we want to keep our brain active, right? What do they say? They say don't rely on the GPS too much. Also know how to direct yourself, and you know how to move around the world without GPS, right? Heaven forbid you don't get signal, but at least you know how to go, right? As much as I would love to stay and participate, I got to deal with life. Okay, I'll see you later, Mio. I'll see you later. We're almost at 20,000. Thank you, everybody. Yeah, we all have real life. And there's no problem with using the calculator. I don't know why people are so judgy. I'm not here to say don't use it. I'm not proud. I'm not preaching. I have to go, okay, Red Mom. The live is recorded or available somewhere for replay. It's recorded, but I haven't taken the time to like post it. So it might take a while. But you know what? I do have like a whole YouTube channel. So if you want to take a look at my YouTube channel, it's all there. As much as I could. That's my name. And I'm always on. I'm always on TikTok. I have twice a day, sometimes 3 times a day. I'm always teaching about abacus. Okay. Yeah, I'm always teaching about abacus. And if you have any specific questions or anything, I do also have a membership as well. If you have any specific questions, and we can talk about it. Okay, so we're gonna do this. Thank you. I'm sorry. Okay, sounds like separate from electrical technology and mechanical technology. Hello, Limitless. I don't know. That's above my pay grade. I don't know. I don't know the difference between electrical technology and mechanical technology. I know the difference between hardware and software. You tell me it's a hardware problem, it's probably a hardware. If it's a problem with the software, it's probably a hardware problem. But I don't know the difference between mechanical and electrical. All right. So, oh yeah. That's my, oh yeah. So if you're looking for more information, I have books available as well. Let's see what book is available. Oh, we don't have that. Okay. Yeah. Abacus and calculator. No, you know what? You know what the difference is? No. You know the difference is the electrical, an engineer and the engineer of a factory and the what do you call it? The manager of the floor. Thank you. Thank you, Red Mom. Thank you. No. It's not a calculator and an abacus. The difference is, would it be the engineer and the manager of the factory floor? The factory floor is like the abacus. You need to know how to use it. You need to understand how it all works. And then the engineer does all the designs and all the pictures. That's what that's what the calculator does. It gives you and it provides you the pictures. And you can modify the pictures, but unless you know how to move the beads, unless you know your numbers, then it'll be one of those things. The difference between arrangements. Yeah, I think that's what it is. We're almost at 20,000. If we can do 20,000, we'll do some multiplication. Yeah, I think that's the difference. Because the abacus is just visualizing your numbers, and it's yeah, I think it's just the essence. Because electrical engineer, you still need to know where the electricity comes from. I'm just assuming, because it says electrical. I'm assuming that you still need to know where everything comes from. Whereas in calculators, you don't need to necessarily know, right? You just need to know how to use it. Because it's about, if you use a calculator, you need to know what to input. Whether or not you know how they're adding, subtracting, multiplying, dividing. That's the basic arithmetic. I don't know. That's a good question. All right, so we're almost at 20,000. Almost. If you guys can tap out the screen, that would be great to tap. The reason why is so then we could tell TikTok. We could tell TikTok that it's doing well. Yeah. The exact versus counting? No. No, you know what it is? No, you know what it is? It's like if you see a picture and you're there. You see a picture of France, you see the Eiffel Tower, that's the picture. As opposed to no. The difference between no, that's not right. That's not right. No. I don't know. I don't know the analogy for that one. Because it's not a calculator does calculations, but you do calculations in your brain. The abacus just shows you the numbers. That's all it does. That's all we're doing. We're just visualizing your numbers. Oh, we're at 20,000. Thank you, everybody. Okay, let's do some multiplication. This is super easy. This will be super easy. I know you could do it in your head, but I'm showing you concepts, right? Your brain is a supercomputer. It's not good comparison to a calculator. Yeah, I'm trying to figure that out. Thank you, Levy. Yeah. You can do a lot more and you can be quicker if you practice the concept of abacus, you could do a lot you could be a lot faster than a calculator. And you know, if you really think about it, the calculator actually started from pen and paper. And it's just like a shortcut. It's really just a shortcut, right? And that's the problem is like we get all these shortcuts and we forget where it all started from. It all started from pen and paper. It all started from, but what the abacus does is just visualize our numbers. So what we're going to do is we're like counting. This is 1, this is 2, this is 3, this is 4, this is 5, right? 6. 5 plus 1 is 6 and 7. 5 plus 2 is 7. We have 8. 5 plus 3 is 8 and then 9. 5 plus 4 is 9. Then we have 10. 10 is a 1 and a 0. The more you train it, easier gets the solution. Training the tool versus the that's a good one, Levy. Yeah, that's a good one. I like that. The more, yeah, you're right. The more you see the different scenarios, the easier it is for you to find the answers because our brains can do it. Whereas a calculator doesn't find the answers for you. You as a person need to input it. Thank you, Venmo. But I'm not looking for the answers. I'm looking for concepts, right? So in Abacus World, we do distributive property. Distributive property is what? Distributive property is, it's a math rule. We break up into smaller parts. We break the numbers up into smaller parts. Yeah, not a problem. Not a problem. No, I understand you could do it in your head, right? But I'm just showing you concepts, how to do it on the abacus. This whole live is all about the abacus and how do we work with the abacus. So we do distributive property. We want to count the amount of digits we have on our abacus. Our answer is going to be 3 digits. This is what it is. Our answer is going to be 3 digits. Why? Because we have 3 digits in our question. So we count 1, 2, 3. It's going to be in the hundreds. So distributive property means what? We take this number and we divide it out. We multiply it out. So we have 5 times 7. What is 5 times 7? We are not going to do 5 times 70. We don't need to do that. Why? Because the abacus keeps track of our number. So what is 5 times 7? 5 times 7 is 35. Thank you. Hello, man. Hello. It is 35. Add the 3, add the 5. And then we do it again. Add the 3, add the 5. So just as Venmo mentioned, the answer is 385. Easy? I know. I know you could do it in your head. But I'm showing you how to do it on the abacus. Thank you. I'm happy you love math. I'm happy that math does not scare you. Okay, we're going to do a few more, and then I'm going to head out. We do another one. 43 times that by 8. It's a puzzle. It is a puzzle. Oh, you're going to like, yeah. I'm going to make advanced abacus questions. Oh, it's going to be good. I just got, the problem is I got to curate all those questions. So again, what is our, where do we put our answer? Our answer is going to be in the hundreds, right? How do I know? Because I'm counting my question. 1, 2, 3. I have 3 digits. Because I have 3 digits, what do? 1, 2, 3. So then we distribute it, right? Distribute property. We do 8 times 4. What is 8 times 4? 8 times 4 is not 344. 8 times 4 is 32. Thank you, Manny. It is 30. It is 2. So notice I do not need to say 8 times 40, right? And I don't need to say it's 320. Why? Because the abacus tracks our numbers. We don't need to use the paper to track the numbers. I don't even need the paper to tell me my multiplication fact. But I'm showing you because I'm teaching you, right? So what we're doing is we're understanding how to do our multiplication fact. We don't need to do 320 because our brain can't really see 320. My brain can. If your brain can, that's fantastic, but my brain can't. So then our next one would be 8 times 3. 8 times 3 is what? 8 times 3 is, I'm sorry, 8 times 3. 8 times 3 is 24. 24. Add the 2, add the 4. So my final answer is 344, just as man said, right? So the answer is 344. So I'm just teaching you the concepts of how to do multiplication on the abacus. We don't need to worry about the zeros because the abacus tracks our numbers. Make sense? Thank you, everybody. So we do it again. We'll do another one. This will be easy. Times that by 2. Again, what are we going to do? Where is it going to sit? It's going to sit in the hundreds column. Hello, Riley. We have 1, 2, 3. 1, 2, 3. So then we have what? 2 times 9. 9 times 2 is 18. Thank you, man. It is 18. We have 1, we have 8. Right? And then what? 4 times 2. 4 times 2 is what? 4 times 2 is 8. Okay. 8 is a single digit. Because 8 is a single digit, we actually need to do some modifications. We need to do some modifications.
You need modifications! Modify! Modify!
Why? We need to change it to a double digit. Double digit is not a foreign concept, right? When we're looking, we want to use the leading 0 because we want to make our single digit a double digit. Just like our time. We have our time 11:03 a.m. p.m. It doesn't matter, right? We can do a 2-digit month, 2-digit day, right, and a 2-digit year. To make the month a 2-digit, we have a 05. This is May. This is May 6th. We also use it when we have money. $2.05, right? That 0 makes it a double digit. The 05 makes it a double digit. So because the 8, because it's a single digit, you got to do 08. The 0 pushes the 8 to here, and we add the 8 here. So my final answer is, what's my final answer? What's my final answer? Thank you. 198. Thank you, Sarah. Yes. How did I get that? Because if you look, anytime the beads are touching the horizontal bar, isn't 18 up the orange? We're not doing 18. We're doing 8. we're doing 8, 0, 8. 198. You forgot. Wait. 18. Right. Sorry. That was my bad. Not 18. 8. 0, 8. When I move, my beads move. So it's 188. Yes, thank you. Sorry. My mistake. So it's 8. So it's 1, 8, 8. Oh, sorry. So 1, and then the top bead. Anytime the beads are touching this horizontal bar, this is counted. So this is counted, and then there's these two counted. So here, when we're looking, this is the 5 plus 3 is 8. Ha! Thank you. 5 plus 3 is 8. Thank you, man. So we have 188. Thank you, Manny. That's the answer. And that's how you read it. So we have the 3, 1, 1, 1. All the bottom beads the value of 1, and then this is the top bead. The top bead is a value of 5. So here, notice the 5 is not touching this horizontal bar, so that's why this is 1. So we have 5. No, this is 1 without the 5. This is 1, and then this is 7. My math wasn't mathin'. Yeah. Well, my abacus was moving. So we have 5 plus 3 is 8. 5 plus 3 is 8. If we did 7, it'd be 5. 5 plus 2 is 7. And then if we did 6, 6 is 5 plus 1. And then again, this is 5. And then we could do 4, 1, 1, 1, 1. This is 4. This is 3. That's 2. And this is 1. There we go. Your abacus was an abin. Yeah. My abacus was adding too much. I don't know. There's got to be something there. What about multi-digit numbers? What about it? You could do it. You could do it on the abacus. You could do it on the abacus, but you would really need to know your formulas. You really need to know how to add the 5, how to add the 5, and you need to know how to add the 10. Because if I start going through that part, then it would get really confusing really quick. Yeah, thank you, Manny. So yes, you could do it. We just got to go through this. But I am going to sign off. Thank you, everybody, for joining. Thank you, everybody, for joining. But yeah, you can do multi-digit numbers, and it'd be same thing. But the thing is you need the foundation of how to make a 5. And hello, Sweet Wonder. Hello, Sweet Wonder. How's it going? Yeah. The biggest thing is understanding how to make a 5 and how to make a 10. If you know how to do that, then doing multi-digit multiplication is super easy. You just need to track your numbers. That's all. So for those of you that are interested, I do have books available in my TikTok shop or over here. My name is Lynette. I've been teaching abacus for about 20 years. It'll be soon 21 years. So I have to up my numbers. Yeah. I have my whole collection of my abacus is over here, and then I'm working on multiplication and division books. But for the most part, if you can add it, you can. If you know these fundamentals, then you can do multi. Hello, Beans. Hello, Beans. I was just about to sign off. I got to get ready for my meeting. How are we today? Good morning. Good morning. Good morning.
Step 2, greet the day, smile, and say, Good morning, city!
For the first graders, I would probably start them off with understanding how to read the beads. So depending on how quickly how big their numbers get, you can start off with the 2-digit, which is 10s and 1s, and this would be the mazes. So they go through all the mazes, right? Understanding how to read the abacus. Or you could do the 3-digit one. It is up to you. I'm glad it's... Oh, thank you so much. Thank you so much, Beans.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
So that would be my recommendation. You can either start with the 3-digit or you can start off with the 2-digit. I am working on a first grade book that'll be published in about a couple of weeks. It is up to you. If you want to start now, you can start off with the mazes. If not, if you want to wait for the other one, we would be doing that. Yeah. It's up to you. Okay, I'll show her these. Yeah, it's up to you. I know the kids. I know everybody really likes the mazes. So it depends on what she's comfortable with. If she's comfortable with the 3-digit, then I would say go with the 3-digit. If she's comfortable with 2-digit, then have her do 2-digit. For the first grader, yeah. Because the more the digits, the more intimidating it is. It's really not that intimidating, but that's just you and me. You know what I mean? So like, if it's a 4-digit number, I know what the more digits they are, the kid starts to break down. So yeah, it is up to you. And I do have available here in my TikTok shop. At the TikTok shop, I do have it with a bundle, so you can purchase the Abacus with the book. It is up to you. But over there in the Amazon, I don't, because I don't have control over that. So it is up to you. Thank you so much for joining. Thank you everybody for joining.
We are so glad you came. Bye-bye. 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 Bye-bye now. Bye. Bye-bye. Remember, please discard all candy wrappers and popcorn containers in the nearest trash receptacle. Thank you. Okay, bye-bye now. Bye-bye. Bye. Okay. Are they all gone? Is everybody gone? Huh? Good. Oh my gosh, my cheeks are killing me. I can't keep smiling like this anymore. I am exhausted. I think I need a break. A little break? Okay.
Yeah. The first graders do get overwhelmed really easily. Thank you, man. I will see you in my next live. Have a good day, have a good night, have a good morning if I don't see you.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Thank you so much, and I'll see you in my next live. Bye, everybody.